Section 3.1, Measures of Center. The focus of this section is to obtain a value that measures the center of a data set. In particular, we present measures of center, including mean and median. Our objective here is not to find the value of each measure of center, but also to interpret those values. A measure of center is a value at the center or the middle of a data set. The mean, or arithmetic mean, of a set of data is the measure of center found by adding all the data values together and dividing the total by the number of data values. Important properties of the mean. Sample means drawn from the same population tend to vary less than other measures of center. The mean of a data set uses every data value. A disadvantage of the mean is that just one extreme value, called an outlier, can change the value of the mean substantially. Using the following definition, we say the mean is not resistant. A statistic that is resistant if the presence of extreme values, that is outliers, does not cause it to change very much. Here's some notation that we use when we present the formulas. We see a summation sign at the top that denotes the sum of the set of data values. X is the variable usually used to represent individual data values. N is the number of data values in the sample, and capital N is the number of data values in a population. So for the mean, X bar is the statistic, the symbol that we use to represent the statistic of a sample, the mean of a sample, and there's this formula for it. And then for the population, we use the Greek letter mu. We use the same formula, but notice in the denominator we're dividing by capital N, which is the number of data values in the population. So an example, data set 32 in your textbook includes measures of data speeds of smartphones from 4 different carriers. Find the mean of the first 5 data speeds for Verizon: 38.5, 55.6, 22.4, 14.1, and 23.5. So quite simply, we're going to add up the 5 values, get 153.7, divide by 5, and we get 30.74. And notice here we carry one more decimal place than the original data values were measured in. So we have 1 decimal in the original data values, so our mean has 2 decimal places. And never use the word average when referring to a measure of center. The word average is often used for mean, but it is sometimes used for other measures of center. And statisticians do not generally use the word average. The median is the measure of center that's the middle value when the original data values are arranged in increasing magnitude. Properties of the median. The median does not change by large amounts when we change a few extreme values, so we say the median is a resistant measure of center. It does not directly use every data value. For example, if the largest value was changed to a much larger value, the median doesn't change. The median of a data value is sometimes represented by X with a tilde over it, or a capital M, or the word MED. To find the median, first put the values in ascending order. If we have an odd number of data values, the median will be the middle data value. If we have an even number of data values, the median will be found by computing the mean of the middle 2 values in the sorted list. So let's go back to those data speeds that we worked with before. We've got 5 of those. We're going to put them in ascending order, and we see here the median is going to be the middle value, which is 23.1. Now let's take one more data value, and we're going to have 6 speeds now. So we put them in order, and we notice there's 2 in the middle now, 23.1 and 24.5, because we have an even number of data values. So we're going to take the mean of the middle 2 values, and we get the median here to be 23.80. Again, notice when we use the median as a calculation here, we're going to use one more decimal place than the original data were collected. If we're just doing it with an odd number of data values, it'll just simply be the data value in the data set. The mode is the value that occurs most frequently. And remember, when we work with frequency distributions, we had modal classes. Important properties. The mode can be found with qualitative data, and a data set can have no mode, one mode, multiple modes. A data set, again, one mode, more than one, or no mode. When it has 2 modes, we say that it's bimodal. And when it has more than 2 modes, we say it's multimodal. And when it has no mode, we just say it has no mode. Find the mode of these sprint data speeds. So we see here that the value 0.3 is repeated 3 times, so that's going to be the mode. And then if we change the data values here to have these data values, 0.3, 0.3, 0.6, 4, and 4, now we have 2 modes. 0.3 and 4, and then if we have this data set, 0.3, 1.1, 2.4, 4.0, and 5.0, there's no repeated value, so we have no mode. The mid-range is the measure of center that is halfway between the maximum and the minimum in the original data set, similar to the midpoint of the classes that we did in the frequency distributions. It's found by adding the maximum data value to the minimum and then dividing by 2. Because it only uses the maximum and the minimum, it's very sensitive to extremes, so we say the mid-range is not resistant, similar to the mean. In practice, the mid-range is rarely used, but it does have 3 redeeming factors. It's easy to compute. It reinforces the idea that there are several ways to calculate or define the center of a data set, and the value of the mid-range is sometimes used incorrectly for the median, so confusion can be reduced by clearly defining the mid-range along with the median. Find the mid-range of those 5 data speeds that we had before. So again, you want to put them in order or notice what's the minimum, what's the maximum. In our data set, the maximum is 55.6, the minimum is 14.1. We're going to add those together and divide by 2, and we get a mid-range of 34.85. For the mean, the median, mid-range carry 1 more decimal place than is present in the original set of values. I mentioned this before. For the mode, leave it as it is unless you're having to do a calculation if you have an even number of values. We can always calculate measures of center from a sample of numbers, but we should always think about whether it makes sense to do that. We should also think about the sampling method used to collect the data. So for instance, in some of these situations, the calculations are not meaningful. So we have zip codes of the Gateway Arch in St. Louis, White House, Air Force Division of the Pentagon, and so forth. So we have 1, 2, 3, 4, 5 numbers there. And these numbers don't measure anything. These are just labels for geographic locations, so we wouldn't take the mean of those. The ranks of selected national universities of Harvard, Yale, Duke, Dartmouth, and Brown were reported as 2, 3, 7, 10, and 14. So we notice this is ordinal data, but taking a mean and a median here would not make any sense because we can't measure the difference between the rankings. And there is a StatCrunch video for this section, and there's a link provided here, and there's also a link provided in my courses for you to look at all the videos for this unit.